Universal time is a time standard based on Earth's rotation. It is a modern continuation of Greenwich Mean Time, i.e., the mean solar time on the prime meridian at Greenwich. In fact, the expression, universal time, is ambiguous, as there are several versions of it. The most commonly used being Coordinated Universal Time and UT1. All of these versions of UT, except for UTC, are based on Earth's rotation relative to distant celestial objects, but with a scaling factor and other adjustments to make them closer to solar time. UTC is based on International Atomic Time, with leap seconds added to keep it within 0.9 second of UT1. Universal Time and Standard Time. Prior to the introduction of Standard Time, each municipality throughout the civilized world set its official clock, if it had one, according to the local position of the sun. This served adequately until the introduction of rail travel in Britain, which made it possible to travel fast enough over long distances to require continuous resetting of timepieces as a train progressed in its daily run through several towns. Greenwich Mean Time, where all clocks in Britain were set to the same time, was established to solve this problem. Chronometers or telegraphy was used to synchronize these clocks. Standard Time, as originally proposed by Scottish-Canadian Sir Sandford Fleming in 1879, divided the world into 24 time zones, each one covering 15 degrees of longitude. All clocks within each zone would be set to the same time as the others, but differed by 1 hour from those in the neighbouring zones. The local time at the Royal Greenwich Observatory in Greenwich, England was adopted as standard on the 22nd of October 1884 at the end of the International Meridian Conference, leading to the widespread use of Greenwich Mean Time to set local clocks. This location was chosen because by 1884 two-thirds of all nautical charts and maps already used it as their prime meridian. The conference did not adopt Fleming's time zones because they were outside the purpose for which it was called, which was to choose a basis for universal time. During the period between 1848 to 1972, all of the major countries adopted time zones based on the Greenwich meridian. In 1935, the term universal time was recommended by the International Astronomical Union as a more precise term than Greenwich Mean Time, because GMT could refer to either an astronomical day starting at noon or a civil day starting at midnight. The term Greenwich Mean Time persists, however, in common usage to this day in reference to civil timekeeping. Measurement. Based on the rotation of the Earth, time can be measured by observing celestial bodies crossing the meridian every day. Astronomers found that it was more accurate to establish time by observing stars as they crossed a meridian rather than by observing the position of the sun in the sky. Nowadays, UT in relation to International Atomic Time is determined by very long baseline interferometry observations of distant quasars, a method which can determine UT1 to within 4 milliseconds. The rotation of the Earth and UT are monitored by the International Earth Rotation and Reference Systems Service. The International Astronomical Union also is involved in setting standards, but the final arbiter of broadcast standards is the International Telecommunication Union or ITU. The rotation of the Earth is somewhat irregular, and is very gradually slowing due to tidal acceleration. Furthermore, the length of the second was determined from observations of the Moon between 1750 and 1890. All of these factors cause the mean solar day, on the average, to be slightly longer than the nominal 86,400 SI seconds, the traditional number of seconds per day. As UT is slightly irregular in its rate, astronomers introduced ephemeris time, which has since been replaced by terrestrial time. Because universal time is synchronous with night and day, and more precise atomic frequency standards drift away from this, however, UT is still used to produce a correction to atomic time, in order to obtain a broadcast form of civil time that carries atomic frequency. Thus, civil broadcast standards for time and frequency usually follow International Atomic Time closely. but occasionally step in order to prevent him from drifting too far from mean solar time. Barocentric dynamical time, a form of atomic time, is now used in the construction of the ephemerides of the planets and other solar system objects, for two main reasons. First, these ephemerides are tied to optical and radar observations of planetary motion, and the TdB timescale is fitted so that Newton's laws of motion, with corrections for general relativity, are followed. Next, the timescales based on Earth's rotation are not uniform and therefore are not suitable for predicting the motion of bodies in our solar system. Versions. There are several versions of universal time. UT0 is universal time determined at an observatory by observing the diurnal motion of stars or extragalactic radio sources, and also from ranging observations of the Moon and artificial Earth satellites. The location of the observatory is considered to have fixed coordinates in a terrestrial reference frame, but the position of the rotational axis if the Earth wanders over the surface of the Earth. This is known as polar motion. UT0 does not contain any correction for polar motion. The difference between UT0 and UT1 is on the order of a few tens of milliseconds. The designation UT0 is no longer in common use. UT1 is the principal form of universal time. While conceptually it is mean solar time at 0 degrees longitude, precise measurements of the Sun are difficult. Hence, it is computed from observations of distant quasars using long baseline interferometry, laser ranging of the Moon and artificial satellites, as well as the determination of GPS satellite orbits. UT1 is the same everywhere on Earth, and is proportional to the rotation angle of the Earth with respect to distant quasars, specifically the International Celestial Reference Frame, neglecting some small adjustments. The observations allow the determination of a measure of the Earth's angle with respect to the ICRF, called the Earth rotation angle. UT1 is required to follow the relationship era equals 2 pi radians, where 2 equals UT1R is a smoothed version of UT1, filtering out periodic variations due to tides. It includes 62 smoothing terms, with periods ranging from 5.6 days to 18.6 years. UT2 is a smoothed version of UT1, filtering out periodic seasonal variations. It is mostly of historic interest and rarely used anymore. It is defined by where T is the time as fraction of the Besselian year. UTC is an atomic time scale that approximates UT1. It is the international standard on which civil time is based. It ticks SI seconds, in step with Ti. It usually has 86,400 SI seconds per day but is kept within 0.9 seconds of UT1 by the introduction of occasional intercalary leap seconds. As of 2015 update, these leaps have always been positive. Whenever a level of accuracy better than 1 second is not required, UTC can be used as an approximation of UT1. The difference between UT1 and UTC is known as DUT1. Adoption in various countries. The table shows the dates of adoption of time zones based on the Greenwich meridian, including half-hour zones. Apart from the Nepal time zone and the Chatham Standard Time Zone used in New Zealand's Chatham Islands, all time zones in use are defined by an offset from UTC that is a multiple of half an hour, and in most cases a multiple of an hour.